Hey everyone, welcome back. We're going to go ahead and move on to 4.3, Properties of Logarithms. The essential question today is, how do I use the properties of logarithms to simplify logarithmic expressions? You may abbreviate to log, I don't really mind. And what we're going to be exploring today are different things, including the change of base formula, as well as the properties of logarithms. The reason we're looking into all of this is that a lot of times when we're solving logarithms, it's actually really difficult to find out what the answer is. For example, if I had log base 3 of 2 and I were asked to solve for that, I actually would have a really difficult time because the answer for that is supposed to be the exponent that helps me get 2, actually a question mark there, if my base was 3. But in order to figure that out, it's kind of like a decimal, and to figure out the exact number will be really difficult. And I can't even put that into my calculator because in a calculator, the logarithm that's used is typically log base of 10. So if I were to enter log 2 into my calculator, for example, right here, log 2, I would come out with 0.30, but that's actually not the decimal that's going to go here as my exponent. So what we need to learn is actually something called the change of base formula that's going to allow us to change things to a log base of 10 that allow us to use our calculator. Okay, so let's go ahead and first copy down the change of base formula, which is from the textbook. So the change of base formula right there has all that highlighted portions, and the most important part is going to be this one, base 10. But go ahead and copy all of the rest as well, because in certain cases we might be asked to change it to something other than a base of 10 just for the sake of practice, or we might have a base with the natural number e. E is something that can only be really used with something called the natural log ln. So that's something we also want to write down for the moment. So if we have something like this with a natural base of e, we can use natural logs and rewrite our equation, okay? So let's go ahead, take these ideas, write down the formulas, and we're going to go ahead and practice a couple of examples with change of base. So for example 1, I'm going to be asked to solve. So we're going to first solve log 6, base 6 of 18. Okay, so if I were to enter this into my calculator again, let's just go ahead and show it. Log of 18, you give me 1.255, and that isn't correct. So let's go ahead and see how we can change this. So log base 6 of 18 can be changed into have a log base of 10 on top and on bottom. The number that we're going to put on top is this value. The number that we're going to have on the bottom is the base value of 6. From here, if you did not have a calculator or a table of values, this would be as much as you could do, and that would show that you know how to change the base. But what we can also do if we had a calculator is actually take the logs. So I have log of 18 there, log of 6, so I get about 1.255 divided by 0.778. So let's do that. And that's going to give me about 1.613. So the actual answer to log base 6 of 18 is 1.613. In other words, 6 to the 1.613 power should equal to about 18. Okay? So the change of base formula, again, allows me to find exact values by using log base of 10, since our calculators and a lot of logarithmic tables have already set up. Okay? So there's example 1. If in the case I had ln of, let's say 24, what I could do would be, let's say this was 7, so ln 7 or ln 24 over ln7. And in there, I can also plug it into my calculator and find the exact values. So ln24, ln7, and then I would just divide those two numbers. For the sake of this example, though, I'll just go ahead and leave it at that, because I want to move into the next set of examples, which are focused on the properties of exponents. Okay? Now, we do have several properties, and I want you guys to, again, copy all of these. So over on page 348, we have 3 properties of logarithms. We have the product property, quotient property, and the power property. So go ahead and copy those in for both the logarithm type as well as the natural log type. I'll focus on just the regular logs for the sake of our examples, but in terms of natural log, it works pretty much the same way. Okay, so basically here, product splits up into an addition problem. Quotient splits up into a subtraction type problem. And here, if you see the power attached to that u value, we actually get to pull the power in front and treat it like as a coefficient in front of the entire log. All right, so with these properties, let's go ahead and do 2 examples. Example 2, part A. Instead of actually solving it, I'm going to ask you to write in terms of log base 4 of 6 and log base 4 of 5. Okay, so the first example is log base 4 of 30. Looking at 30 and knowing that I have to work with 6 and 5, I know immediately that 6 times 5 will get me 30. So I can rewrite this guy as log base 4 of 6 times 5, 5 times 6, doesn't matter. And because I have a product here, I can split it up into a sum. Log base 4 of 6 plus log base 4 of 5. What's the point of this? It's to work with some smaller values. Technically, I could evaluate this by changing the base, but I can also work with this in case I was only given the values for this, supposing that I didn't have a calculator, and I was only given the values for these two. Okay, so there might be some problems where we have to do that. For now, I'll just show you how to split things up. And then example B, we have log base 4 of 125 over 36. So we have 2 things being combined here. The first part, let's go ahead and split these up into exponents. So 125 can be written as 5 cubed, 36 as 6 squared. This is a quotient, so I can go ahead and split this up again into log base 4 of 5 cubed minus log base 4 of 6 squared. And the power rule now lets me simplify this just one step further. I can bring down this 3, and I can bring down this 2. So my final answer will be 3 log base 4 of 5 minus 2 log base 4 of 6. Again, if I were given certain values, I would be able to plug in, I would be able to calculate, but for the sake of this example, we'll go ahead and stop right there. If you need to replay, go ahead and do so. Otherwise, move on to the Google Forms, and have a great day, you guys.